Astronomers look deep into the young universe and find something that should not be there yet. Bright points appear in the darkness. Observations are checked. Distances are measured. The objects remain exactly where they were found, and the numbers attached to them refuse to get smaller. Some of these black holes already contain billions of times the mass of the Sun. That discovery creates an immediate problem. The universe at that stage is still young. There has not been much cosmic time for anything to grow, yet something enormous is already sitting there, fully visible across vast distances. The usual expectation begins to weaken. Large black holes are supposed to be the result of time. More time allows more growth. Less time should mean smaller results. But the observations point in the opposite direction. The farther back astronomers look, the more they encounter objects that seem to have arrived ahead of schedule. The result arrives before the process is supposed to finish. Something massive appears in the record before it seems to have had enough time to form. The question is no longer whether these objects exist. The question is, how much time is actually missing? Astronomers try to save the timeline. If these black holes seem impossibly large, perhaps they simply grew faster than expected. The calculations are pushed harder. The feeding process is stretched toward its limits. Growth continues almost without interruption. Mass keeps pouring in. The black holes become larger, then larger again. But the clock keeps moving too. Even under extremely favorable conditions, the numbers struggle to reach what is actually being observed. Growth is no longer the obstacle. Time is. The black holes keep getting larger on paper, but the universe keeps running out of years first. Each attempt runs into the same barrier. The black holes start small. They grow rapidly. They continue growing. Yet when the calculation reaches the age of the young universe where these objects are already visible, the final result still falls short. That changes the nature of the mystery. At first, the black holes seemed unusual. Now the timeline itself begins to look unreliable. The simplest explanation, that ordinary small seeds had enough time to grow into these giants, starts losing ground with every calculation. The black holes have not changed. The clock has become the suspect. There may not be enough time for the standard sequence of events to unfold at all. And if the timeline cannot stretch any farther, another possibility begins to appear. Maybe these black holes did not begin their lives small. The timeline does not immediately break. A different possibility begins to take shape. Instead of starting as tiny seeds and spending enormous amounts of time growing, some black holes may have entered the universe with a head start already built in. Researchers propose a more direct beginning. Massive gas clouds gather, they collapse, and rather than passing through the usual sequence of small starting points, they may produce unusually large black hole seeds from the beginning. That changes the picture immediately. A black hole that starts larger does not need to spend as much time growing. Part of the journey is already complete on the day it forms. Suddenly, the distance no longer looks impossible. Part of the distance has already been crossed before the story even begins. Some of the required growth disappears because the starting line moves forward. For the first time, the tension eases. Maybe the timeline was never broken. Maybe the earliest black holes simply began life much larger than expected, reducing the amount of growth needed before astronomers eventually observed them. The idea does not solve the mystery completely. For the first time, the numbers stop fighting each other, and if that path is correct, future observations should gradually make the timing crisis fade rather than deepen. The explanation appears to gain ground. If some black holes begin with unusually large seeds, then the timeline no longer has to perform the impossible. The early universe gains breathing room. The largest objects become easier to place inside the available time. Then the universe refuses to cooperate. More distant regions are examined. More early structures appear. Every expansion of the search seems to reveal another object that arrived too soon. Instead of reducing the tension, the growing inventory begins to extend it. Unexpectedly massive black holes continue showing up. Unexpectedly massive galaxies begin appearing as well. The pattern spreads beyond the original problem. What first looked like a small number of difficult objects starts resembling a broader population that arrived earlier, larger, or more developed than expected. The fix starts falling behind the discoveries. A larger seed can help explain a black hole that starts ahead, but each new observation adds another demand on the timeline. The challenge is no longer confined to a few extreme cases sitting at the edge of the data. Additional discoveries keep appearing in places where the timeline was expected to become easier to reconcile, not harder. The problem is changing shape. The earlier solution is not discarded. It may still explain part of what is being seen, but it no longer feels large enough to absorb every new observation on its own. The breathing room disappears. Not because the original discrepancy vanished and came back, but because the observational picture expanded faster than the repair. The black hole seeds are no longer carrying the whole mystery. Attention begins turning toward the broader assumptions used to model how structures in the early universe grow in the first place, and that raises a more uncomfortable possibility. What else inside the timeline is becoming difficult to trust? The black holes do not disappear. Their role changes. They stop looking like the mystery. They start looking like the evidence. Each new discovery pushes attention away from a handful of unusual objects and toward the timeline used to describe the early universe itself. Stars appear, galaxies assemble, black holes grow. Those events are not separate stories. They are connected parts of the same process. If multiple parts of that process seem to be advancing faster than expected, then the question becomes larger than any single black hole. Attention moves away from what was found and toward the process that was supposed to create it. That does not mean the existing picture is wrong. It means the picture may still be incomplete. Some part of early cosmic growth may be operating differently, more efficiently, or under conditions that are not yet fully captured by current models. That is why these black holes matter. Not because they prove a dramatic new answer, not because they overturn everything that came before, but because they expose a place where observation is advancing faster than explanation. The giant black holes are not the final problem. They are the clue that exposed it. The real question is no longer how those black holes became so large. It is whether the timeline describing the universe's earliest growth is still missing part of the process itself.